Hi, okay, so we're going to do a little bit of fraction subtraction now. And yeah, you're welcome to work through them with me. Let me find this. There you go. Okay, so number 1, 3/4, take away or subtract 1/4. So they're quarters and quarters, so we can put quarters at the bottom, and 3 subtract 1 or 3 take away 1 is 2. And because we can divide the top and bottom by 2 because they're both multiples of 2, how many 2's fit into 2? 1. How many 2's fit into 4? 2. So what we're doing there is because it's an equal sign, we're dividing by the same number to keep the fraction the same. 2/4 is still a half, but we simplify it. If you had a big number like 500 1,000ths want something, it's easier to say half of the people want something. The information is easier to transfer between people and it makes more sense. So number 2, 3/4 take away a half. Now we've got different numbers at the bottom, so we need to find an equivalent fraction. Because it's 3/4, and if we want to change quarters to halves, we need to half the 4 to make the 2, but then we'd have to half the 3 to make it 1.5. So it's more comfortable to change the half. So let's find equivalent fraction to 1/2 and turn it into quarters. So we know 2 times 2 is 4, so what we do to the bottom we have to do to the top to make it fair, and 1 times 2 is 2. So we're going to, now I'm going to put equals because I did that with the one before. 3/4 take away 2/4. So we've got quarters and quarters, so we can keep quarters at the bottom, and 3 take away 2 is 1. And that's our answer. Okay, let's do a grey. Number 3, 1/3 take away 2/7. Let me check. 1/3 take away 2/7. Right. Now I can't make thirds into sevenths or sevenths into thirds, just because 2 3s are 6 and 2 7s are 14. So, or half of 7 is 3.5. So we need to think of a number that both of them are factors of. So sometimes it's good to multiply them. So we're going to do that. We're going to turn thirds into something else. Oh, I'm going to use a different colour. Let's just do this then. Let's do, okay. Now, what we need to do is have a common denominator. We want to have 3 times 7. So we're going to have 20/1ths, 21 at the bottom. So we do 3 multiplied by 7 is 21. So we've got to do the same to the top. 1 times 7 is 7. 7 multiplied by 3 is 21. So 2 multiplied by 3 is 6. 1/3 is 7 21ths. Take away 2/7 is 6 21ths. So we've got 21s at the bottom, or 21ths. 7 times 6, take away 6 is 1. So we've got 1 over 21 there. I'm just going to go down a little bit. And we're on number 4. So number 4 is 4/5 take away 4/9. 4/5 take away 4/9. Again, we've got different denominators. So they're both factors of a number, and we're trying to have the same number at the bottom, aren't we? So we could count up in nines until we have a multiple of 5. And we know it's a multiple of 5 if the ones digit is a 0 or a 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45. So it's still going to be 5 times 9. 5 nines are 45, and that gives us our multiple. Five times 9 is 45. 9 times 5 is 45. So here, so 5 multiplied by 9 is 45. 4 times 9 is 36. Let's change the colour. So 9 multiplied by 5 is 45, and 4 multiplied by 5 is 20. Okay, so let's rewrite these. 4/5 is the same as saying 36 45ths. 4/9 is the same as saying 20 45ths. So 45ths take away 45ths and 45ths is going to stay at the bottom because this is the number of 45ths we've got. We've got 36 45ths, take away 20 45ths is 16 45ths. Now, I don't think I can simplify that anymore because let's have a look. The factors of 16 are 1 times 16, 16. 2 multiplied by 8, and whoops, we've got 4 in the middle because it's a square number. I can fit 1 into 45. 2 doesn't fit in, excuse me. I hope I'm not setting you off. 4 won't fit in because it'd be 44. 8, no. 16, no. So it stays like that. Okay, 16 45. Let's do number 5. Okay. 2/3 take away 4/15. 2/3 take away 4/15. 3's fit into 15 because 5 3's is 15. So I'm going to turn 2/3 into 15ths. It's always useful to look at both numbers and find out if you can fit one into the other. So 3 times 5 is 15. So 2 multiplied by 5 is 10. So instead of writing 2/3, we write 10/15. Because 2 5's are 10 and 3 5's are 15. Take away 4/15. So we've got 10/15, take away 4/15 is 6/15. Now I know that 6 is a multiple of 3 and 15 is a multiple of 3, so I'm going to divide the top and bottom by 3. Six divided by 3 is 2, and 15 divided by 3 is 5. So our answer is 2/5. Okay, number 6. Let's take it right down. There we are. Right, 1/2 take away 5/12. All right, so I want 1/2 to turn it into 12ths. So I multiply 2 by 6 to make 12, so I need to multiply 1 by 6. So now I've got my 12ths. So I rewrite it as 1/2 is 6/12, subtract 5/12. 6 take away 5 is 1. We've got 1/12 left. Okay, I think I've got 2 more. That's different enough. Number 7, 4 subtract 2/7. Now, every number has a denominator. But when we're talking about 4, we're talking about 4 footballs, 4 whole footballs, 4 whole pizzas. And whole is 1. So it might be more comfortable to write it like this then. Okay. Actually, let's write it a bit better than that. Okay. So now what we need to do is we need to alter this fraction to make it into 7ths. So to turn 1 into 7 over an equal sign, you multiply by 7, and 4 multiplied by 7 is 28. So now we have our 4 wholes, but in 7ths, so we can sort them out. So 28/7, take away 2/7 equals 26/7. Now we've got an improper fraction there. I'm just going to do this. Just to make it a bit more obvious. Okay, so I'm going to play around with this fraction now. We've got 26/7, and that's the same as saying 7/7, and then that's 14/7, and this is 21/7, and 21, 22, 23, 24, 25, 26/7. Can you see that 3 times 7 is 21, add 5 is 26? You've got 1 whole, plus another whole, plus another whole, plus 5/7. So that's 3 and 5/7. So these are exactly the same fractions. They're just shown differently. I'll just check. 26, 7, 3 and 5/7, yeah. And let's do one more. Make it clear. It's a bit curly. I haven't quite got the hang of doing those on this yet. Okay, 9 take away 14/15. That's how you'll probably see it. That's exactly the same as saying 9 wholes take away 14/15. No difference. Now I'm going to do this slightly differently. 14/15 is 1/15 of being a whole. So say if you've got, I'm going to go back to cake or pizza. Say if you've got massive pizza and it's cut into 15 slices in a round, and 14 of them have been eaten. How many slices have you got left? 1. If there's a big pizza and it's split into 15 slices and 14 of them have been eaten, you've got 1 slice left. So it's nearly a whole, but it's not quite. So what I'm going to do is I'm going to make it a little bit easier on my head, and I'm going to split this up, this 9 up. So I'm going to, instead of doing this, I'm going to say 8 plus 1, which is 9, take away 14/15. Now I'm going to say 8 plus, what is 1 in 15ths? If it's the whole thing, it's 15/15. So 8 plus 15/15, take away 14/15. Now you haven't got these massive numbers to be calculating now, and it's something that's really worth trying to understand this. So I split 9 into 8 and 1. I've kept the 8 because I don't need to be messing with it. It's not something I need to touch. I don't need to be dealing with massive numbers. I only needed to change this one because that number is less than 1. 14/15, point to the smallest, is less than 1. So if it's less than 1, I can change it. I can work with it, with just this. So I've got 8 plus, now 15/15 take away 14/15 is 1/15. So that's 8 and 1/15 is your answer. Now, had I done it the other way, this is what it would look like. Okay, so let's work it out a different way. Let's just see which is better. All right. So if I had 9 wholes and take away 14/15, and I turn the 9 wholes into 15ths. So we're doing multiply 1 times 15 is 15 and 9 times 15. Well, 9 times 10 is 90. 90 add 45 is 135. So now what we're going to do is we're going to write 9 wholes as 15ths. Okay, so 135 take away 10 is 125. Take away 4 is 121. Okay, so we're going to work out how many 15ths that is. So 121/15 is equal to 15/15. That's another 15, so that's 30/15. 45/15. 60/15. 75/15. 90/15. 105/15. 120/15 plus 1/15. So that's 1, 2, 3, 4, 5, 6, 7. So the answer should be 8 and 1/15. Okay. So looking at that, sorry, I made it really messy there. Looking at that, which strategy do you prefer? Which has got the less chance of making an error? That one. Yeah. Why am I writing over and making a real mess? Okay, let's have a look. Let's try and just tidy it up a bit. So it's that one. So much simpler. Look at the difference. So what it's really useful you doing is understanding why this is what it is, rather than, oh, I've got to change all of that into what the denominator is. It's understanding to stop and look at it, and that's quite a challenge, but it's a challenge you can absolutely do. So that is the end of this lesson now, and I will go on to multiplication and division soon, and see you. Right, let me just say proper goodbye, whilst I'm being rude. All right, so I will speak to you again soon, and have a good rest of the day. Take care. Bye.